Have you ever watched a self-driving car glide through traffic and just wondered, how? I mean, really, how does it see everything? How does it make decisions in the middle of all that chaos? Well, today we're going to pull back that curtain and get right into the science that makes it all tick. To kick things off, I absolutely love this quote from our source. It's just perfect. Forget some cold, sterile machine. Think of it as your own personal, super intelligent robot chauffeur. That really sets the right tone for what we're about to unpack. So, here's the secret. The whole incredibly complex system, it really boils down to 3 simple steps. First, the car has to see the world. Then, it has to think about what it's seeing. And finally, it has to act. See, think, act. That's our roadmap for today. Let's start at the beginning, with seeing. Right, so how does a car see? Well, it's not just about having a couple of eyes. Oh no. It's equipped with a whole array of super senses, and each one is like a different superpower. Check this out. You've got LiDAR, which is literally shooting out lasers to build this perfect 3D map of everything, total Iron Man vibes. Then you've got radar, which is kind of like a vibe detector. It's amazing at sensing how fast other things are moving. Of course, there are cameras, the car's actual eyes for reading signs and traffic lights. And for those really tight spots, like parking, it's got ultrasonic sensors, which is basically the tech equivalent of a helpful auntie guiding you in. But here's the thing, and this is what's so cool. None of these sensors is perfect on its own. Look at this. LiDAR is incredible in the dark, but it can get confused by heavy rain. Radar can see right through fog, no problem, but the picture it gets isn't super sharp. And cameras, well, just like our eyes, they can get totally blinded by sun glare. So they all have to work together, like a team, covering for each other's weaknesses. And that teamwork has a name. It's called sensor fusion. This is where the magic really happens. The car's brain takes all that info from the lasers, the radar waves, the cameras, and it blends it all together. The source material has the best analogy for this. It's like a chef making biryani. You take all these totally different ingredients, mix them up just right, and you get one perfect, delicious dish. That's how the car gets one single, super accurate picture of the world. Okay, so the car can see. It's got this rich, detailed picture of the world. Now for the truly mind-bending part, what does it do with all that information? How does it actually think? So the very first thing the brain has to do is make sense of everything. It's not enough to just see a bunch of pixels or laser points. It needs to know, okay, that blob of points is a car, and that moving shape is a person. This whole process of understanding is called perception. And perception involves a few really cool jobs. First, there's object detection. That's finding and labeling everything, whether it's another car, a person, or hey, even a cow in the middle of the road. Then there's something called semantic segmentation, which is like a coloring app for the real world, digitally painting the road one color, the sidewalk another. And finally, there's tracking, constantly following all those objects, almost like a cricket commentator predicting where the ball's going to go next. All right, so the car has a pretty good idea of what's around it. But, that's only half the story. To make any kind of useful driving decision, it has to be able to answer one really, really basic question. And that's where localization comes in. We're talking way, way more precise than the GPS on your phone. The car uses GPS, sure, but it also combines it with other sensors. And, this is the key, these incredibly detailed HD maps. These maps have everything, every lane marking, every curb, every sign. All of that together lets the car know exactly where it is, down to a single centimeter. Okay, the car knows what's out there. It knows precisely where it is. But the road is not a static place, right? Things are constantly moving, so the next massive challenge for the brain is to figure out what everyone else is about to do. And I just love this quote for explaining the next step, prediction. The AI basically becomes this super gossip queen, constantly trying to predict everyone's next move. It's analyzing that cyclist, that auto rickshaw, that person on the sidewalk, and it's running all these probabilities. Are they going to turn? Are they going to cross? What are they going to do next? So once it has all that data, what's there, where it is, and what everyone might do, it's finally time to make a plan. And this happens on 2 levels. First, you've got the high-level behavior planning. This is the big picture stuff, like deciding, okay, now is a good time to change lanes. It's like a chess player thinking 3 moves ahead. Then you've got low-level motion planning. This is the nitty-gritty, calculating the exact smoothest possible path to actually make that lane change without spilling your chai. So we've seen, we've thought, and now for that final, crucial step in the process, act. This is the moment where all that digital thinking turns into real, physical movement on the road. This part is all handled by the control system. It takes the plan, that turn the wheel 5 degrees left, gently hit the brakes command, and translates it into actual electrical signals to the steering, the accelerator, and the brakes. And the goal here is to be incredibly smooth and precise, so the ride feels totally natural, not like it's zigzagging all over the place. But here's the most important takeaway. This isn't just a one-time thing. It's a constant, super fast feedback loop. The car sees, thinks, acts, and then it instantly sees the result of that action and starts the entire cycle all over again, thousands of times a second. It's like a teacher who's constantly checking your homework and making tiny little corrections in real time. See, think, act, and repeat. So that's the fundamental process. But of course, that opens up some really big questions. Like, how can we possibly be sure all of this is safe? And what kind of insane computer power does it take to pull this all off? Well, as you can imagine, safety is everything. It's built in at every single level. You've got these strict international safety standards. You've got specific protocols to make sure the car doesn't just freak out if one of its sensors has a momentary glitch. And of course, you have layers and layers of cybersecurity to keep the hackers out. So how do you actually practice and test for every crazy thing that could happen on the road? I mean, you can't just drive around forever hoping you see it all. The answer is simulation. Engineers run these cars through billions of virtual miles in these hyper-realistic digital worlds, and the source material has the absolute best way to describe it. Imagine GTA, but for engineers. And to actually perform that constant see, think, act loop requires a mind-boggling amount of processing power. We are talking about a supercomputer on wheels, packed with specialized GPUs and neural chips that are crunching a gazillion calculations every single second. It is just an incredible amount of brain power. So there you have it. From lasers and cameras that see the world to a super brain that can perceive, predict, and plan its every move, the technology is getting smarter and more capable every single day, which really just leaves us with one last big question to chew on. The technology is learning to drive. Are we ready to be passengers?